Okay, so one of the first things is we need to measure the length of what we're measuring the resistance of. Now, we're going to choose an appropriate instrument. Now, here I've got a half meter ruler or a meter ruler. Half meter will be appropriate because the range of measurements is going to be up to about 32 to 33 centimeters. The precision is 0.1 centimeters, which is 1 millimeter, which is the smallest division that I have on the measuring instrument. So 1 millimeter is my precision, and the range that I have on this measuring instrument is appropriate for all the measurements I could do on my copper wire. Now, if I'm measuring 5 centimeters, a precision of plus or minus 1 millimeter is quite appropriate. If we calculate an uncertainty, that gives me a small percentage uncertainty. But if I move on and I start measuring the diameter to get the cross-sectional area is something like 2 millimeters. Now, my precision on my meter ruler is 1 millimeter. My measurement's close to 2 millimeters. So that's going to lead me to an uncertainty of about 50% in my measurements. Okay, now you guys are going to be calculating the percentage uncertainties, deciding if they're reasonable, but I think it's fairly clear that having a percentage uncertainty or percentage error of 50% is not good. So I need to use something else to measure the diameter. One possibility is that I switch to vernier calipers. Now, the vernier caliper has jaws, so what I do is I place the object in the jaws and I rest the jaws on each side, and then I can take a reading. There's a lock here that I can use to stop it from moving. So just check that we're there. That is the diameter. I've locked off, so it's not going to change hopefully. And then I'm going to take a reading off the scale. Now, here I've got centimeters and millimeters, so the precision on this scale is to the nearest plus or minus millimeter. With the vernier caliper, the vernier scale gives me another little scale here. Now, if you look closely, you can just make out that here is a whole centimeter divided into millimeters. Okay, so I've got 10 little lines, and what I need to do is my measurement of this diameter, I'll count along the horizontal scale here. I can count up to 1 millimeter, 2 millimeters, 3 millimeters, and then the actual measurement is between 3 and 4. If I look at this scale here, I have to choose the line on this scale that matches one of the lines on the upper scale. Right? One of the lines on this scale here that matches a line on the upper scale. Now, I'm going to have a look. So I've got 1, 2, 3 millimeters, and then I would say the best line here that matches up, see it there, best line that matches up is the fourth one along this one. This one best matches with the line on the top scale. So that means 0.4 of a millimeter. So my measurement here is 1, 2, 3 millimeters on the normal scale, the bottom scale. This one this scale here, 4 millimeters, and then it's the fourth one on this tiny scale here, this little scale here, which is what we call the vernier scale. It's the fourth one along on that one, so that's going to be 3.4 millimeters. So the vernier calipers allow me to get a measurement to the nearest 0.1 millimeters, okay, which is higher precision than my meter or half meter ruler. And also, the handy thing about a vernier caliper is you don't just have a measurement to measure objects, the diameter of an object, but you can also use the opposite jaws to measure the size of a hole. For example, unlock it. These are for measuring the internal diameter. These ones here measure the internal diameter, which is quite handy. But for this, I'm not going to use a vernier caliper. The range of this is going to be 0 up to about 12 centimeters. Okay. Precision to the nearest plus or minus 0.1 millimeters, which is a good level of precision. But for very thin bits of wire, still not good enough. So vernier calipers can be put away. And what I'm going to do is I'm going to use something called a micrometer. This is a screw micrometer, because as I'm adjusting it, it's not something sliding backwards and forwards. This is a screw that for one whole turn, so I start off at 0, I turn the screw and I watch the scale go, one whole turn is half a millimeter. 2 turns is a millimeter. Now, to use this, again I've got 2 scales like a vernier caliper. I've got a normal scale in millimeters, which is on the barrel here, the inner barrel. So if I go up to 1 centimeter, there you can see 1 centimeter or 10 millimeters, and that's the space there. So if I'm measuring something quite thin, a copper rod for example, is just as good. What I do is I place the copper rod in my micrometer. The jaws I have here I tighten. As I'm getting close to tightening up, the problem is if I turn this barrel, a whole turn is half a millimeter. I can exert a lot of force here with not so much force, a little force here. So what I have on the end is a ratchet which will click, and that will stop me exerting too much force. I can then lock, and as long as I've not squashed too much there, I can then remove this. The lock is in position and I can take my reading. Now the way to use it is, we start off on the inner barrel. On the top, if we can see here, let me get closer. On the top I've got 1mm, 2mm, 3mm, 4. On the bottom of there I've got half millimeters, so 0.5, 1.5. Each full turn of this barrel will move this bit of the scale here, the line of the barrel, will move it forwards. One full turn will move it half a millimeter forwards or half a millimeter backwards. So for my copper rod, I've taken a measurement of 0, 1, 2, 3, and I'm not at 3.5 because I can't see the line on the bottom. So I've got 3 millimeters, and then if I look at the scale here on this barrel, I've got 15, 16, 17 when I get to this central line. That means I've got in millimeters 3.17 millimeters diameter. Now, taking measurements like this, one thing that I need to introduce is the fact that we could have a 0 error on our measuring instrument as well. So we've got to check, first of all, are we using the appropriate measuring instrument? Is the range appropriate for what we're going to measure? I wouldn't be using this half-meter ruler to measure distance to China. Not appropriate. I wouldn't also be using this to measure the diameter of my copper rod, because the precision is not precise enough. So first thing to consider is range, and the second thing to consider is precision. And we need a level of precision that's going to give us a small percentage uncertainty during our experiment. Now, here, what is this, 3.17. Now, how do I check if I've got a 0 error? If I screw in, and to avoid squashing the metal here, I ratchet, I need to check that this is on 0. Okay, and at the moment what I'm seeing is that, if you look closely, I'm actually 0.01 millimeters away from 0. So I'm going to adjust this in a moment. These ones, this one is actually, when it's closed, 0.04 millimeters away, because I sabotage this one. And this one is 0.02 millimeters, and it's 0.2 millimeters in the opposite direction, so it's minus 0.02 millimeters. Now, a 0 error would produce this same minus 2, or this is plus 0.4. This same error will be introduced to all the measurements that I make. So a systematic error is an error like a 0 error. This is not aren't at 0 when I start off, and that same error is introduced in every single measurement that I take. Okay. If you draw it on a graph, you can see pretty clearly that the lines wouldn't cross the origin. They would be a bit higher, and it is quite easy to correct afterwards, a systematic error. But what I'm going to do is I'm going to adjust this so it's perfect before I start.